All right, we are on to procedure part C. So talking about particle size. So I have measured out and crushed 10 grams of rock salt here. And then to show you a comparison, there's my uncrushed rock salt. I have my 50 milliliters of water in my beakers, and I'm going to put my salt, my crushed and uncrushed beakers, salt into the beakers at the same time, or as close as I can get, right? So there's my uncrushed, there's my crushed, and now we're gonna see dissolving time. We're just gonna compare our rate. So which is dissolving faster? I can tell you right now, our crushed rock salt certainly appears to be dissolving faster. I still have really big chunks of salt in my beaker B, and beaker A is almost all the way dissolved. That looks pretty close to being dissolved. There's still certainly a couple chunks on the bottom. We might have reached our saturation point with our water. Oh, I might be close actually. I need a couple more particles in there for our crushed salt. This guy still has lots and lots of big pieces of rock salt in there, and A is nearly dissolved. So we can conclude, you can kind of see those little pieces in there, right? But compared to all of these gigantic pieces in here, we can conclude that if you have a larger particle, it is more challenging to dissolve, and it's all to do with surface area. So the more surface area that something has, so like in our smaller chunks of particle, because there's a lot more smaller pieces, there's a lot more surface area, so it's able to dissolve at a much quicker rate than the giant chunks of rock salt. All right, so hopefully you're able to answer those questions. Does particle size affect how quickly a solute dissolves? And then how could I get the rock salt to dissolve more quickly, right? So the smaller the particle, the faster it will dissolve. And if you want to get the rock salt to dissolve quickly, you crush that up. All right, good job.